True or false are challenging, so I want you to make sure you're thinking through all cases. So every elementary row operation is reversible. Yes, because you can undo the switching two rows, you can multiply a row by the additive inverse of the other and add it to another row, or you can multiply a whole row by the reciprocal of what you multiplied through by. So those 3 elementary row operations you need to know. So the pivot positions in a matrix depend on row interchanges are used in the row reduction process. No, it's false. The pivots are the leading ones whenever you're doing RREF, right? So that does not matter. It does not matter if you're doing row interchanges because that's one of the elementary row operations. Echelon form of a matrix is unique. No. The echelon form is like saying REF. The RREF is unique, and that's where all the pivot positions are 1s, and you have 0s above and below those pivots. REF just means you have pivot positions of 1s, and you have 0s below your pivot positions of 1. Basic variable in a linear system is a variable that corresponds to a pivot column. Yes, so we identify them by going in the row to find out the pivot, but the pivot column does tell us what the basic variable is. A 5x6 matrix has 6 rows. No, if it's a 5x6, it's 5 this way and 6 this way. So it has 6 columns and 5 rows. Whenever a system has a free variable, then it contains many solutions. No, this is a place where I could have a free variable, but there's not many solutions. This second row here, if it's a system, that means it's augmented. This one tells me it's inconsistent. So an inconsistent system has more than one solution is false, because when it's inconsistent, that means there's no solution. All right, finding a parametric description of the solution set is the same as solving the system. Yes, so parametric means we're going to have the parameter, or we're going to have a free variable, and we still can find the solution that way. So 2 fundamental questions about a linear system are existence and uniqueness. Correct. Existence means a solution exists, so it's consistent. And if it exists, we always want to know, is it unique or is it the infinitely many? So those are the 2 big questions. Row reduction applies to augmented matrices. No, you can use, that's false, you can use row operations on a regular just coefficient matrix or just a matrix. Doesn't matter. Augmented or just a matrix. You can use row operations. If every column of an augmented matrix contains a pivot, then it's consistent. No, if it's an augmented matrix, I could have the last row have a pivot in that column. That makes it inconsistent, because this last row would mean 0 equals B, and that's not true. 2 matrices are row equivalent if they have the same number of rows. No, you got to do row operations. Just having the same number of rows doesn't make them the same. 2 linear systems are equivalent if they have the same solution set. Yes, same solution set means you did row operations to get from one to the other. Row reduction algorithm or process applies only to augmented matrices? No, not at all. It's the same question as this. You could use it for augmented matrices or just regular matrices, coefficient matrices. And do they make you think? Yes, they do. They're a little challenging.